So what we're going to look at in this particular lesson is looking at how we can configure a global exception handler in ASP.NET Core, so that instead of surrounding our code with try-catch blocks to get this kind of result where we're passing the error down to the client and actually handling the exceptions, we can do this at a global level so that ASP.NET Core does the handling on our behalf, and we can alleviate the problem of writing lots of try-catch blocks. So let's head back into VS Code, and first of all let's just clean up our login method. I'll just remove this try-catch block. I'm going to keep the throw exception in there. We'll still make use of that, and I'll just get rid of the catch as well. And I have one extra bracket somewhere. And the good thing about this bracket pair colorizer is I know that this blue one is the start of my login action, and that means this purple one is the one I need to get rid of. And I'll just reformat. And now we're back to how we were. We've still got our exception, but this time we're going to handle this globally rather than surrounding our code with try-catch blocks. So in order to do this, and we'll go back to our startup class, and we're already making use of our developer exception page here, and in the else block, if we're not in development mode, then we'll make use of the global exception handler. So what we do is we say app.use exception handler, and this exception handler adds middleware to our pipeline that catches exceptions. It logs them and then re-executes the request in an alternate pipeline. So what we could do is just close this off here, and then this would just simply send back a 500 internal server error, but it would be handled globally rather than being unhandled. We can go a step further in this, and we can actually configure this. And this returns an iApplication builder, and we'll just specify builder as our option here, and we'll add an expression. And we'll say builder.run, and using this run command adds terminal middleware delegates to the application's request pipeline. And inside here we can access our context. So we'll say async context, and context in this case is related to our HTTP request and response. So I'll say context, and then context.response .status code, and in here we can control the status code we return when we handle an exception. So we'll keep this as we were before. We'll say HTTP status code and .internal server error, and we need to bring in using system.net and just terminate this line, and then we'll go out and get the details of the error. So we'll store this in a variable called error, and we'll say context.features.get, and we'll use the iException handler feature, and we'll also need to bring in the ASP.NET Core diagnostics here, and this error is going to store our particular error in this case. So we'll say if the error is not equal to null, then we'll say await context.response.write async, and then we'll pass in our error.error.message, and we'll bring in write async from ASP.NET Core HTTP, and all we're doing here is writing the error message into our HTTP response as well. And I'll just add a semicolon here, and we'll go and test to see what we get now, because bear in mind we've taken away our try-catch block, and previously when we tested this, and when we tested in production mode by the way, because our startup class is still going to return a developer exception page in development mode, but now in production mode, or something else other than development, it's going to return something different. So let's go back to Solution Explorer, just go back to our launch settings.json, and I'll just change this back to production, and I'll just restart my server. And let's go back to Postman and see what happens now when I send my request to log in. This time I still get a 500 internal server error, and this time I get computer says no. So that's the result we're looking for. If I check on my client and I do the same thing, I'll just refresh the page and go back to the console and type in Bob and password and try and log in, then I still get this weird looking request. I still get this no access control origin header is present on the requested resource. But we know for sure we're not returning a developer exception page at this stage. So let's examine our network request and take a look at our login and see what we're getting back from our server. And we're getting this 500 internal server error. And if we look at the response headers, then we're not actually getting our cause headers. So we're still getting this misleading response from our server because it's not adding our cause headers onto this particular request. And if we go back to VS Code just to take a look at the reason why this is, and I go back to my startup class, when we go into our exception handler, which we have done in this case, and we use this run method, then we're executing our request now on a different pipeline and we're returning the response from this exception. And all we're returning is this message, but this message doesn't have any cause headers applied to it. So what we're going to need to do is modify our response a bit further from our exception so that we don't see those misleading errors. And what we want to do is add something else to our response in this case. And what we're going to do in this particular example is we're going to extend this response so that we can add our own custom application errors to this response. And what we're going to use for that is what's referred to as an extension method. So for instance, one of the methods available in the response class is write async or toString or send file async, etc., etc. But we're going to add our own extension method here so that we can choose add application error and we'll be able to select it from this particular list. So in order to do this, we'll go back to Solution Explorer, and inside our API, just in the root of this folder, I'm just going to add a new folder, and this one's going to be called helpers. And inside here, I'm just going to add a new C# class, and I'm going to call this extensions.cs. And this particular class is going to be a sort of general purpose extensions class that we'll use for any other extension methods we need in addition to this one. Now, because it's an extension method, we don't want to create a new instance of this extensions class in order to make use of any methods inside it. And to do that, we'll make this method or this class a static class. And this static keyword means that we don't need to create a new instance of extensions when we want to use one of its methods. And the extension method we'll add will say public static void, because we don't want to return anything from this particular method. And we'll say add application error. And in order to overwrite our response, we need to overwrite we say this and HTTP response. And we'll need to bring in ASP.NET Core HTTP, and we'll call it response. And we also want to pass the message into this as well. So we'll say string message. And inside our response, we'll use this to add additional headers onto our response. So we'll say response headers.add, and we'll call this header application-error, and we'll pass it the message. We'll also add another response header, and in this case we'll add the cause header so that our Angular application doesn't moan about it because it doesn't have the appropriate access control, allow origin, etc. And the first one we'll add is access control, expose headers, and then we need to give it the name of the header we want to expose, in this case application error. And we'll also need to add response.headers.add access control, allow origin, and we'll use the wildcard to effectively say allow any origin. So in the event of an exception, when we send this back to our client, there's going to be a new header in there called application error, and it's going to have the error message as its value. And then these other two headers are simply to allow this to be displayed. So let's head back to our startup class. So just before the write async, we'll say context.response.add application error. And we'll need to bring in our helper's namespace that we've just added. So I'll add this. And in here, we'll pass it our error.error.message as its parameter. So with this in place, this is going to add a new header into our response. And if we go back and take a look at this, I'll just need to stop and restart the server. First of all, we're still in production. So we're using our global exception handler. And I'll just resend this request in Postman first of all. And we get our computer says no. And if we take a look at the headers we're returning, we can see we've got our access allow origin this time. And we're exposing the application error header. And inside the application error, it says computer says no. And that's the response we're returning now. So if we go back to our client, and I just refresh the page, I'll go back to the console, and I'll just try and log in as Bob again. This time I get an internal server error, and I get failed to log in. We're not doing anything with the error at this point. We're still just simply returning this, and I'll be able to see this in the network tab. And if I click on login, inside the headers, I can see that I've got access to the response headers now that are related to our error. And we'll be able to make use of these in our Angular client and display notifications to the user about what went wrong. We could redirect them to another page. We can really do whatever we want once we start getting the information back from our server. So the next step in handling errors is to take a look at it from our Angular application, and that's what we'll take a look at next.